Here is a detailed summary of the CBSE 10th Science Chapter 3. Metals and Non-Metals, structured specifically to help you build an engaging and educational AI video project for your examination point of view. This video will also be useful for the students located at remote places. Part 1. Physical properties and exceptions. This section contrasts the basic traits of metals and non-metals while highlighting the plot twists, exceptions that make great visual hooks. Metals. Metallic luster. Pure metals have a shiny, reflective surface. Hardness. Generally hard, though it varies significantly by element. Malleability. Can be beaten into ultra-thin sheets. Gold and silver are the absolute best at this. Ductility. The ability to be pulled into thin wires. For example, just 1 gram of gold can stretch into a 2 kilometers long wire. Conductivity. Excellent conductors of heat and electricity. Silver and copper are the champions. Lead and mercury are relatively poor conductors. Home wiring is coated with PVC or rubber to prevent shocks. Sonority. They make a ringing sound when struck, which is why school bells are metallic. Non-metals found as solids or gases, with bromine as the lone liquid exception. They are bad conductors of heat and electricity. The major exceptions: mercury, that is Hg, element number 80 in periodic table. The only metal that stays liquid at room temperature. Gallium and cesium. Metals with such low melting points they will literally melt in the warmth of your palm. Iodine. A non-metal that defies the rules by being highly lustrous or shiny. Carbon allotropes. Diamond is a carbon non-metal but ranks as the hardest known natural substance. Graphite is another form of carbon but conducts electricity perfectly. Alkali metals like lithium, sodium, potassium. Metals so incredibly soft you can cleanly slice them with a kitchen knife. Part 2. Chemical properties. (1) Reacting with oxygen and air. Metals combine with oxygen to form metal oxides. Example: copper plus oxygen turns into CuO, that is, turns into a black copper oxide layer. Sodium and potassium are highly reactive alkali metals. When exposed to atmospheric oxygen and moisture, they oxidize rapidly, releasing extreme heat that triggers spontaneous combustion. Storing them completely submerged in kerosene or mineral oil blocks air and moisture, keeping them stable. (2) Reacting with water. Metal plus water turns into metal oxide plus hydrogen. Sodium and potassium explode violently in cold water. The hydrogen gas catches fire instantly. Calcium and magnesium react more gently and actually float because the hydrogen bubbles stick to their surfaces. Aluminium, iron, and zinc completely ignore cold or hot water but react violently with steam. Gold, silver, and copper totally unreactive with water. 3. Reacting with acids and the royal water. Metals react with dilute acids to produce salt and hydrogen gas. Aqua Regia, royal water, a highly corrosive, fuming liquid made from a freshly prepared in 3:1 ratio of concentrated hydrochloric acid, that is HCl, and concentrated nitric acid HNO3. It is famous because it can dissolve gold and platinum, even though neither acid can do it alone. Part 3. The reactivity series and compounds. The reactivity series, a ranking system of metals from most reactive potassium, sodium to least reactive silver and gold. Displacement. A more reactive metal will aggressively kick out or displace a less reactive metal from its salt solution. Ionic compounds. Formed when metals give up electrons to non-metals, like sodium giving an electron to chlorine to make sodium chloride. Properties. They are brittle solids, have incredibly high melting, boiling points, dissolve easily in water, and conduct electricity only when dissolved or melted. Never in solid state. Part 4. Metallurgy and extraction. The industrial scene. How we get these elements out of the Earth's crust. Ores are mined filled with impurities called gangue. Extraction depends entirely on reactivity. Low reactivity metals can often be extracted by heating alone. Heating cinnabar, that is HGS, yields pure mercury. Medium reactivity metals, that is sulfides and carbonates. Roasting. Heating strongly in excess air. For sulfide ores. Calcination. Heating strongly in limited air, for carbonate ores. Thermit reaction. A spectacular displacement reaction where iron oxide iron 3 oxide reacts with aluminium powder. It generates so much extreme heat that the iron melts instantly, which is used on site to weld cracked railway tracks together. High reactivity metals cannot be reduced with carbon. They require electrolytic reduction, passing massive electrical currents through molten chlorides to force the metal to deposit at the cathode. Electrolytic refining. Purifying metals like copper, using in chemical bath where impure metal sits at the anode, and pure metal grows on the cathode. Part 5. Corrosion and prevention. The real-world impact scene. Silver turns black from sulfur in the air. Copper turns green from moist carbon dioxide. Iron develops a brown flaky rust from oxygen and water. Prevention armor. Painting, oiling, anodizing, or galvanization, that is coating iron or steel with a defensive layer of zinc. Alloying. Mixing a metal with other elements to alter its traits. Pure iron is too soft, but adding just 0.05% carbon makes it incredibly strong. Mixing iron with nickel and chromium creates stainless steel, which completely resists rust. Historical wonder. The Iron Pillar at Delhi. Built over 1,600 years ago by ancient Indian metallurgists, this 8-meter-high, 6-ton pillar stands completely exposed to the elements but has resisted rusting for over a century, baffling modern scientists. Thank you for watching this video. Like, share and subscribe.